Hi everyone, and welcome to our second video in the Prep Set Go series. In this video, we'll be discussing how to properly assess and prepare substrates for the application of various coatings and floor finishes. And we'll cover the whole process from the initial visual inspection and assessment, what to look for, and any specific preparation and remedial processes required. We'll be focusing primarily on concrete surfaces as it's one of the most common substrates in construction. So mastering how to prepare concrete correctly will provide a good basis for addressing alternative substrate types. Now, surface assessment and preparation represents the first step in any application. Now, whether it's resilient flooring, waterproofing, or general coatings, the fundamentals of surface preparation remain the same. And while it might not be the most glamorous or enjoyable part of the job, it's certainly one of the most critical, because the performance and long-term integrity of any flooring system is directly related to the suitability, integrity, and level of preparation of the surface it's applied to. Adequate surface preparation can determine the success or failure of the system. So it's crucial to invest the time and effort in this initial stage. And we've been in the game for a long time and can tell you how many times the lack of surface preparation has been the primary reason for a system failure. So in layman terms, if you fail to prepare, you're preparing to fail. It's that simple. There are many considerations and factors that determine the suitability of a surface for product application. So let's explore some of the more basic considerations. A simple visual inspection will reveal a lot on the condition and suitability of the substrate. So what are these primary considerations? So one of the first things to look at is cleanliness. It's pretty basic. So cleanliness is a very generic term for the condition of a surface. So what do we mean specifically? Well, the surface should be free from loose material like dirt, dust, general rubbish, plasterboard, top coat, and general construction materials, to name a few. Generally, any objects not integral or not bonded to the substrate. So we always start with an initial sweep of the surface to remove all the larger and obvious objects, which gives us a better view of the surface underneath and anything further that needs to be addressed. A thorough vacuum of the surface will then remove all the smaller particles and the smaller dust. Next, we ensure the surface is free from bonded contaminants, meaning any foreign material that may be bonded to but not actually part of the substrate. And this includes things like grease, oils, wax residues, curing compounds, existing paint and coatings, adhesives and sealant residues, corner cement and other compounds, to name a few. Anything that can be considered a bond breaker that prevents the applied system from adhering directly to the surface. Now, these contaminants will require a bit more effort to clean by either using chemicals such as degreasers for grease and oils, to manual scrapers, wire brushing, and mechanical grinding. So while cleaning, it's also important to remove any organic matter, things like mold, mildew, fungus, etc., because this will require chemical treatment to kill the spores and stop it propagating under the applied finish. So why is this step important? What's the risk if these contaminants aren't removed? Well, the primary risk of applying anything over surfaces that aren't properly cleaned is peeling or delamination. Now, this is because there's no meaningful adhesion or bond directly to the substrate, which is required for the coating or finish to perform as intended. You're effectively bonding to the surface contaminants that are not part of the substrate and are either loose or incompatible with the overlaid finish. Our next consideration is surface stability and integrity. Concrete substrates should be a single, solid and stable mass to properly support any overlaid finishes. There shouldn't be any weak or defective layers or obvious faults like extensive cracking or major deterioration. For new concrete, things to check for include latents. Now, latents is a weak, powdery material that forms on the surface of concrete, typically due to an excess of water in the concrete mix. It rises to the top and creates a slurry cement layer that dries on the surface, and you can tell it's far softer than concrete should be. If you run something sharp over the surface and it powders up or makes an impression on the surface, this is generally evidence of latents. For older concrete, surfaces can become brittle and friable over time and subject to continuous dusting. In both instances, mechanical treatment, including grinding, shot blasting, or similar methods to remove these defective layers is required. And as with other surface contaminants, the defective layers weaken the direct bond between the finish and a stable base. So any further degradation or breakdown, movement or delamination of these layers will transfer to the surface finish. Now, concrete spalling and concrete cancer is where the steel reinforcement inside the concrete corrodes and is typically due to moisture exposure. And this can cause the concrete to crack and peel away. And concrete cancer is the term commonly used for the spread of concrete spalling. And the only way to stop this is to expose and treat the affected steel and replace the damaged concrete. Now, surface cracks. All concrete is subject to surface cracking, and the extent and the severity is determined by a number of different factors. New concrete will typically form micro-cracking, which is usually caused by rapid water evaporation, but are superficial and minor in nature. Cracking in older concrete surfaces can be down to excessive structural movement or settling of foundations. Now, live cracks are of a particular concern, and they are cracks that expand and continue to propagate in the concrete surface. Now, this can cause cracking through more rigid finishes like tiles and cause drumminess and delamination. Liquid coatings and decorative floor finishes aren't designed to bridge wider cracks, so they can transfer through to the coating. Static cracks should be opened and filled with a suitable repair compound, while live cracks will need specialist treatment. For surfaces with extensive cracking, a structural engineer's report is always a good idea. Now on to our final consideration. As a general rule, surfaces should be smooth, flat, and relatively level. They should be free from heavy undulations, pitted areas, deep recesses, and voids. It should be one continuous plane, especially when applying finishes directly to the surface. Now, how flat a surface needs to be is relative to the surface finish. For example, vinyl flooring requires an exceptionally smooth, level, and uniform surface, as these defects will show through the finish. Now, RLA produces a number of surface preparation products to create smooth surfaces, which we'll explore in later episodes. Liquid coatings, including waterproof membranes and epoxy coatings, are not designed to span or fill gaps and voids and can develop pinholes and other defects when applied over heavily undulated and pitted surfaces. Coverage rates and film thicknesses of liquid coatings will also be affected. More material will be needed the rougher the surface is, and film thickness will also be compromised over sharp and protruding objects. Tiling systems are a little bit more forgiving given their capacity to build up the adhesive bed. However, the consumption should also be considered. The use of levelling compounds, repair mortars and fairing coats to ensure a smooth, consistent and uniform finish across the whole substrate is universally accepted and an economical way of preparing the surface. So, in summary, the importance of a thorough inspection, assessment and preparation of the substrate cannot be stressed enough, and it's often the difference between the success or failure of the overlaid system. Now, we're all mindful of time constraints and deadlines, but by investing the time early on in the installation, the rest of the job will work significantly smoother and some of those efficiencies will be recovered. Good surface prep not only simplifies the actual installation, but also gives you peace of mind and confidence of the long-term durability of the system. Now, a big thank you to everyone who's joined us for this episode of Prep, Set, Go. It's great to have you along. Please feel free to send us any comments, questions, or topics you'd like us to cover in future episodes, and we hope to see you in the next instalment. Goodbye.